Quantum Numbers by Mackenzie Lowe and Zoe Bai. Now we want to recall that in the Rutherford diagram of an atom, the nucleus is small and in the center of the atom. The Heisenberg model of the atom, the size and shape of the atom is determined by the orbitals of the electrons that orbit the nucleus. There are 4 quantum numbers: principal, secondary, magnetic, and spin. These 4 numbers describe where electrons are located around the nucleus of the atom. Think of this set of numbers like an address. To know where your friends live, you must have 4 pieces of info to determine their exact address, just like quantum numbers. Imagine the city being the principal quantum number, a large, not specific location. The street being the secondary quantum number, a little more specific. And the house number being the magnetic quantum number, this being very specific. As well as the spin quantum number. These 4 numbers determine the exact location of an electron with no other set of numbers describing that location. Let's take a closer look. Principal. Principal quantum numbers tells you the general area of where the electron is. They are the shell number, represented by the letter N. Shell numbers are whole numbers starting at 1. Now going on to secondary. Secondary quantum numbers is the orbital shape within the subshell, also known as a sublevel shape. It is represented by the letter L and can be calculated by principal quantum number minus 1. There are 4 possible shapes: sharp, principal, diffuse, and fundamental. Now if L equals 3, this applies to all shapes. This can be all shapes. This is a picture of all the shapes. Now going on to magnetic quantum number. Magnetic quantum number is the number of orbitals within the sublevel. It is represented by m sub L and can be calculated by negative L to positive L, including 0. Refer to orbital shapes from L values. The magnetic quantum number are the names for each orbital. And the number of orbitals is the number of ways to draw the shapes. Sublevels have multiple versions because of vectors. Vectors are made up of 2 parts, a magnitude and a direction. Moving on to spin quantum number. Spin quantum number is represented by m sub s and differentiates between the 2 electrons on the orbital. Although electrons ordinarily repel each other, magnetic forces keeps electrons on the same orbital. Magnetic force is generated by the spinning of electrons. We label the electrons as half or negative half. Now let's do an example. We want to identify the quantum numbers for each of the electrons in the carbon atom. Because carbon has 6 electrons, this means carbon will have 6 sets of quantum numbers. To start this problem, we begin at the first shell, represented by N. N equals 1. L equals 0 because if you recall, L equals n minus 1, and since n equals 1, L equals 0. The magnitude is also 0 because if you recall, magnitude is determined from negative L to positive L, and since L equals 0, magnitude is also 0. And spin quantum number is positive and negative half. Now moving on to the second shell level, n equals 2, L equals 0 and 1, and magnitude is negative 1 and 0, and again, spin is negative half and half. Now we can look to the right and display all of the quantum numbers from electron 1 to 6.